In stationary, residential, backup power systems, it's generally required to keep the grounding and neutral conductors separate. This requirement arises because the transfer switch does not switch the neutral, and the neutral is not permitted to be grounded more than once within the system. This configuration is often referred to as a separately derived system. According to the 2005 National Electrical Code, Section 250.24, it explicitly states that the bonding connection between the grounded conductor and the equipment grounding conductor shall be made at the service entrance or at the first disconnect on the load side of the service entrance. This code provision means that the essential bond between the grounded conductor, commonly known as the neutral, and the equipment grounding conductor, frequently called the ground, must be established at the first point of disconnect on the load side of the utility meter. Now let's address an approach some competitors are taking. The method of connecting 3 wires from the generator to the transfer switch, while simultaneously leaving the bond intact between the grounded conductor and the equipment grounding conductor in the service panel, directly violates the aforementioned code requirement. This practice introduces an unsafe condition. This occurs because the neutral and ground could inadvertently become bonded at multiple points throughout the electrical system. Such multiple bonding can potentially create electrical hazards, compromising the safety and integrity of the installation. In conclusion, it is explicitly not permitted to bond the neutral and ground conductors in the service panel when installing a backup power system that employs a non-neutral switch and transfer switch. The correct and code-compliant approach is to separate the grounding and neutral conductors at the first disconnect located on the load side of the utility meter. Subsequently, a 4-wire configuration, which includes 3 hot wires and 1 neutral wire, should be run from this point to the transfer switch. This practice ensures full compliance with the NEC requirements and, most importantly, maintains the safety of the electrical system. When dealing with electrical systems, adherence to established codes and regulations is paramount. This is because electrical installations are inherently hazardous, and any deviation from standard practices can have serious consequences. Firstly, ensure proper grounding and bonding. Grounding provides a low impedance path for fault current to return to the source, tripping the circuit breaker and de-energizing the circuit. Bonding ensures that all metallic parts of the electrical system are at the same potential, reducing the risk of electric shock. Secondly, maintain separation of neutrals and grounds. In a properly wired electrical system, the neutral conductor should only be grounded at the service entrance. Grounding the neutral at multiple points can create circulating currents and increase the risk of electric shock. Thirdly, use appropriate wiring methods. The NEC specifies different wiring methods for different applications, such as non-metallic sheath cable for residential wiring and rigid metal conduit for industrial wiring. Use the correct wiring method for the specific application to ensure safety and prevent damage to the wiring. Fourthly, provide overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Install overcurrent protection devices with the correct ampacity rating for the circuit to prevent overheating and fires. Fifthly, follow manufacturer's instructions. Electrical equipment should be installed and used in accordance with the manufacturer's instructions. This includes using the correct voltage and amperage ratings, as well as following any specific installation procedures. Sixthly, inspect and maintain electrical systems regularly. Electrical systems should be inspected and maintained regularly to identify and correct any potential problems. This includes checking for loose connections, damaged wiring, and corroded components. Seventhly, hire qualified electricians. Electrical work should only be performed by qualified electricians who are familiar with the NEC and local electrical codes. This ensures that the work is done safely and correctly. Eighthly, understand separately derived systems. A separately derived system is an electrical system that is not directly connected to the utility power source. This includes generators, solar power systems, and uninterruptible power supplies. Separately derived systems have specific grounding requirements that must be followed to ensure safety. Ninthly, be aware of arc flash hazards. Arc flash is a dangerous electrical explosion that can occur when there is a short circuit in electrical equipment. Wear appropriate personal protective equipment, such as arc-rated clothing and face shields, when working on or near energized electrical equipment. 10thly, use ground fault circuit interrupters. Ground fault circuit interrupters are designed to protect people from electric shock by detecting ground faults and quickly interrupting the circuit. Install ground fault circuit interrupters in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. In understanding the intricacies of electrical installations, several key concepts must be thoroughly grasped to ensure safety and compliance. Firstly, impedance is the total opposition that a circuit presents to alternating current. It is similar to resistance in a direct current circuit, but it also includes the effects of inductance and capacitance. Understanding impedance is crucial for calculating voltage drops, fault currents, and selecting appropriate overcurrent protection devices. Secondly, fault current is the current that flows during a short circuit or ground fault. Fault current can be very high and can cause significant damage to electrical equipment. It is essential to calculate fault current to select appropriate overcurrent protection devices that can safely interrupt the fault current. Thirdly, voltage drop is the decrease in voltage along a conductor due to the impedance of the conductor. Excessive voltage drop can cause equipment to malfunction and can also increase energy consumption. Calculate voltage drop to ensure that the voltage at the end of the circuit is within acceptable limits. Fourthly, ampacity is the current carrying capacity of a conductor. The ampacity of a conductor is determined by its size, insulation type, and installation conditions. Select conductors with sufficient ampacity to carry the expected load current without overheating. Fifthly, grounding electrode system is a system of interconnected grounding electrodes that provides a low impedance path to earth for fault current. The grounding electrode system typically consists of a ground rod, a metal water pipe, and a concrete encased electrode. Install a proper grounding electrode system to ensure that fault current can safely return to the source. Sixthly, bonding jumpers are conductors that connect metallic parts of the electrical system together to ensure that they are at the same potential. Bonding jumpers are used to bond metal conduits, metal enclosures, and metal equipment to the grounding electrode system. Install bonding jumpers correctly to reduce the risk of electric shock. Seventhly, surge protection devices are devices that protect electrical equipment from voltage surges, such as lightning strikes and power grid disturbances. Surge protection devices divert surge current to ground, preventing it from damaging sensitive electronic equipment. Install surge protection devices to protect valuable electrical equipment. Eighthly, harmonics are distortions of the sinusoidal waveform of alternating current. Harmonics can be caused by nonlinear loads such as electronic equipment and variable frequency drives. Harmonics can cause overheating of electrical equipment, increased energy consumption, and interference with communication systems. Mitigate harmonics by using harmonic filters or by selecting equipment with low harmonic distortion. Ninthly, power factor is the ratio of real power to apparent power. Power factor indicates how efficiently electrical power is being used. A low power factor can cause increased energy consumption and can also require utilities to install larger equipment to supply the same amount of real power. Improve power factor by using power factor correction capacitors. Tenthly, energy efficiency is the measure of how efficiently electrical equipment uses energy. Energy-efficient equipment uses less energy to perform the same task, reducing energy consumption and saving money. Select energy-efficient equipment whenever possible to reduce energy consumption and minimize environmental impact. In the realm of electrical safety, several critical precautions must be meticulously observed to mitigate potential hazards. Firstly, de-energize circuits before working on them. Always turn off the power at the circuit breaker or disconnect switch before working on any electrical circuit. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Secondly, use insulated tools. Use tools with insulated handles when working on electrical circuits to protect against electric shock. Ensure that the insulation on the tools is in good condition and is rated for the voltage of the circuit you are working on. Thirdly, wear personal protective equipment. Wear appropriate personal protective equipment such as safety glasses, rubber gloves, and insulated boots when working on electrical circuits. This equipment will help protect you from electric shock, arc flash, and other hazards. Fourthly, avoid working in wet conditions. Do not work on electrical circuits in wet conditions, as water is a good conductor of electricity and can increase the risk of electric shock. If you must work in wet conditions, use extra caution and wear appropriate waterproof clothing and footwear. Fifthly, never bypass safety devices. Never bypass safety devices, such as circuit breakers, fuses, and ground fault circuit interrupters. These devices are designed to protect you from electrical hazards, and bypassing them can create a dangerous situation. Sixthly, follow lockout/tagout procedures. Follow lockout/tagout procedures when working on electrical equipment to prevent accidental energization of the equipment. Lockout/tagout procedures involve disconnecting the power to the equipment and placing a lock and tag on the disconnect switch to prevent it from being turned on. Seventhly, inspect electrical equipment regularly. Inspect electrical equipment regularly for signs of damage, such as frayed wires, cracked insulation, and loose connections. Repair or replace any damaged equipment immediately. Eighthly, use extension cords safely. Use extension cords safely by not overloading them and by not running them under rugs or furniture. Overloaded extension cords can overheat and cause a fire. Ninthly, be aware of overhead power lines. Be aware of overhead power lines when working outdoors. Maintain a safe distance from overhead power lines to avoid contact, which can be fatal. Tenthly, know the location of emergency shut-off switches. Know the location of emergency shut-off switches in your workplace. These switches can be used to quickly de-energize electrical equipment in the event of an emergency. In ensuring electrical system reliability, several key practices should be consistently implemented. Firstly, conduct regular inspections. Conduct regular inspections of electrical equipment and systems to identify potential problems before they cause failures. Inspection should include visual checks, as well as electrical testing. Secondly, perform preventive maintenance. Perform preventive maintenance on electrical equipment and systems to extend their lifespan and prevent failures. Preventive maintenance includes tasks such as cleaning, lubrication, and tightening connections. Thirdly, maintain accurate records. Maintain accurate records of electrical equipment and systems, including installation dates, maintenance activities, and repair history. These records can be used to track equipment performance and identify potential problems. Fourthly, use high-quality components. Use high-quality components when installing or repairing electrical equipment. High-quality components are more reliable and will last longer, reducing the risk of failures. Fifthly, provide adequate ventilation. Provide adequate ventilation for electrical equipment to prevent overheating. Overheating can cause equipment to fail prematurely. Sixthly, protect equipment from moisture. Protect electrical equipment from moisture, as moisture can cause corrosion and electrical failures. Use waterproof enclosures and sealants to protect equipment from moisture. Seventhly, provide surge protection. Provide surge protection for sensitive electronic equipment to protect it from voltage surges. Voltage surges can damage or destroy electronic equipment. Eighthly, use uninterruptible power supplies. Use uninterruptible power supplies for critical equipment to ensure that it continues to operate during power outages. Uninterruptible power supplies provide backup power in the event of a power failure. Ninthly, implement redundancy. Implement redundancy in electrical systems to provide backup in the event of a component failure. Redundancy can be achieved by using multiple power supplies, multiple circuits, or multiple pieces of equipment. Tenthly, train personnel. Train personnel on the proper operation and maintenance of electrical equipment. Properly trained personnel are more likely to identify and correct potential problems before they cause failures. Considering the impact of electrical systems on energy efficiency, several strategies can be employed to minimize energy consumption. Firstly, use energy-efficient lighting. Use energy-efficient lighting, such as light-emitting diode lamps, to reduce energy consumption. Light-emitting diode lamps use significantly less energy than incandescent lamps and also last much longer. Secondly, use energy-efficient appliances. Use energy-efficient appliances such as refrigerators, washing machines, and dishwashers to reduce energy consumption. Energy-efficient appliances are designed to use less energy to perform the same tasks as standard appliances. Thirdly, install programmable thermostats. Install programmable thermostats to automatically adjust the temperature in your home or office based on your schedule. Programmable thermostats can help you save energy by reducing heating and cooling costs when you are not at home or at work. Fourthly, seal air leaks. Seal air leaks around windows, doors, and other openings to prevent drafts and reduce energy loss. Sealing air leaks can help you save energy by reducing the amount of heating and cooling required to maintain a comfortable temperature. Fifthly, insulate walls and ceilings. Insulate walls and ceilings to reduce heat transfer and save energy. Insulation helps to keep your home or office warmer in the winter and cooler in the summer, reducing heating and cooling costs. Sixthly, use window coverings. Use window coverings such as blinds, curtains, and shades to block sunlight and reduce heat gain in the summer. Window coverings can also help to insulate your home or office in the winter. Seventhly, turn off lights and appliances when not in use. Turn off lights and appliances when not in use to save energy. Even small appliances can consume a significant amount of energy over time. Eighthly, unplug electronics when not in use. Unplug electronics when not in use to prevent phantom loads. Phantom loads are the energy that electronics consume even when they are turned off. Ninthly, use power strips. Use power strips to easily turn off multiple electronics at once. Power strips can also help to protect electronics from power surges. Tenthly, conduct an energy audit. Conduct an energy audit to identify areas where you can save energy. An energy audit can help you identify air leaks, insulation problems, and other energy inefficiencies. In addressing the complexities of the National Electrical Code, several key areas deserve meticulous attention. Firstly, Article 100. Article 100 provides definitions for terms used throughout the NEC. Understanding these definitions is essential for correctly interpreting and applying the code. Secondly, Article 110. Article 110 covers general requirements for electrical installations, including working space around electrical equipment, guarding of live parts, and identification of conductors. Thirdly, Article 210. Article 210 covers branch circuits, including requirements for conductor size, overcurrent protection, and receptacle placement. Fourthly, Article 220. Article 220 covers feeder and service calculations, which are used to determine the appropriate size of conductors and overcurrent protection for feeders and services. Fifthly, Article 230. Article 230 covers services, including requirements for service conductors, service equipment, and grounding. Sixthly, Article 250. Article 250 covers grounding and bonding, which are essential for electrical safety. This article includes requirements for grounding electrode systems, equipment grounding conductors, and bonding of metal parts. Seventhly, Article 300. Article 300 covers wiring methods, including requirements for cable types, conduit types, and installation methods. Eighthly, Article 310. Article 310 covers conductors for general wiring, including requirements for conductor size, insulation type, and ampacity. Ninthly, Article 400. Article 400 covers flexible cords and cables, including requirements for cord types, ampacity, and use. Tenthly, Article 430. Article 430 covers motors and motor circuits, including requirements for motor protection, motor control, and motor disconnecting means. Furthermore, here are some additional points to keep in mind. Understand the scope of the NEC. The NEC applies to most electrical installations in the United States, but there are some exceptions. Check with your local authority having jurisdiction to determine whether the NEC applies to your specific project. Stay up to date on code changes. The NEC is updated every 3 years, so it is important to stay up to date on the latest code changes. You can purchase a copy of the NEC from the National Fire Protection Association or access it online through various subscription services. Consult with a qualified electrician. If you are not familiar with the NEC, it is always best to consult with a qualified electrician. A qualified electrician can help you ensure that your electrical installation is safe and code compliant. Obtain necessary permits and inspections. Before starting any electrical work, obtain the necessary permits and inspections from your local authority having jurisdiction. Permits and inspections help to ensure that the work is done safely and in accordance with the NEC. Follow manufacturer's instructions. Always follow the manufacturer's instructions when installing electrical equipment. The manufacturer's instructions will provide specific information about the proper installation and operation of the equipment. Use approved equipment. Use only equipment that is approved by a recognized testing laboratory such as Underwriters Laboratories. Approved equipment has been tested to meet safety standards and is more likely to perform safely and reliably. Protect wiring from damage. Protect wiring from damage by using appropriate wiring methods and by installing wiring in locations where it is not likely to be damaged. Damaged wiring can create a fire hazard or an electric shock hazard. Use appropriate overcurrent protection. Use appropriate overcurrent protection such as circuit breakers and fuses to protect electrical circuits from overloads and short circuits. Overcurrent protection devices should be sized according to the ampacity of the conductors they are protecting. Ground electrical equipment properly. Ground electrical equipment properly to provide a path for fault current to flow back to the source. Grounding helps to prevent electric shock and fire hazards. Test electrical installations. Test electrical installations after they are completed to ensure that they are safe and code compliant. Testing should be performed by a qualified electrician.